You have left the galaxy, and the first thing you notice is the silence of the light. Not darkness, not yet. Just a thinning. The stars behind you, the ones that make up the spiral arms of the Milky Way, are still visible, still burning, still arranged in the structure you spend your entire life looking up at from the surface of a small planet on one of those arms. But they are behind you now, all of them. Every star you have ever seen with your naked eye, every constellation, every myth your species ever drew in the sky, all of it is behind you and receding, and the view in front of you is something that no human nervous system was designed to process. Not because it's violent, not because it's loud, because it is so empty that the emptiness itself becomes a presence. Space between stars is empty in a way that feels relative. There are still stars nearby, still a neighborhood, still context. Space between galaxies is empty in a way that feels absolute. In every direction ahead of you, there is nothing for 2.5 million light years. The nearest galaxy to the Milky Way, Andromeda, is a faint smear ahead of you at this distance, barely distinguishable from the background glow of the intergalactic medium. You are in the void between them. You are in a place that the universe seems to have left deliberately blank. And the further you go, the more it becomes clear that you are not traveling through space. You are traveling through an absence that has been here since before the Earth existed, and that will be here long after everything you came from has gone cold. Turn around first, look at what you left. From outside the Milky Way, from a distance far enough to see its full structure, the galaxy is incomprehensible in the most specific sense of that word. Not incomprehensible the way a large number is incomprehensible, where you understand the concept but lose the scale. Incomprehensible the way a living thing is incomprehensible when you are too small to see all of it at once. The Milky Way from outside is a barred spiral galaxy, a flat disk of stars with two dominant arms and several minor ones trailing outward from a central bar, the whole structure rotating slowly around a supermassive black hole at its core. 4 million solar masses of gravitational singularity keeping 100 billion stars in orbital motion, like a slow, vast clock that has been running for 13 billion years. The disk is 100,000 light years across and roughly 1,000 light years thick at the arms. The central bulge rises several thousand light years above the plane. At this distance, with the right instruments, you can see the glow of it. The aggregate delight of 100 billion stars compressed by distance into something that looks almost like a single softly glowing object. It is the most beautiful thing in your visual field. It is also the only familiar thing left. Because beyond it, in every other direction is a darkness so profound and so populated with repetition. Other galaxies, other structures, all of them impossibly far, that the word alone cannot hold what it means to see it in person. But here's the problem. You are not just far from home. You are in an environment that operates by different rules than the space you left. The intergalactic medium, the material that fills the space between galaxies, is not a true vacuum. It is a plasma, a diffuse web of ionized hydrogen and helium so thin that it contains roughly 1 atom per cubic meter, compared to the millions of atoms per cubic meter in the interstellar medium inside a galaxy. This is close enough to nothing that the distinction feels academic until you need it not to be. Because moving through this plasma at any significant fraction of the speed of light produces effects. High-energy particles accelerated to relativistic speeds interact with even this near vacuum, producing secondary radiation, and the intergalactic medium, sparse as it is not evenly distributed. It is threaded through by magnetic fields from the large-scale structure of the universe itself, cosmic filaments of matter that connect galaxy clusters like strands in a web, carrying currents and fields that interact with anything moving through them in ways that are still being mapped and modeled by physicists on Earth who have never and will never send an instrument here. And it gets worse, because the intergalactic void is cold in a way that the word cold was not built to contain. The temperature of the intergalactic medium in the deepest voids between galaxy filaments approaches the temperature of the cosmic microwave background radiation, approximately 2.7 degrees Kelvin, 3 degrees above absolute zero, the base temperature of the universe. The thermal remnant of the Big Bang still filling all of space uniformly after 13.8 billion years of expansion and cooling. This is not the cold of deep space within a galaxy, where at least stellar radiation provides some baseline warmth. This is the cold of the universe's floor, the minimum, the temperature below which the laws of thermodynamics do not allow you to go, except at the singularity of time itself. Any object that stopped generating its own heat in this environment would cool toward this temperature and stay there. Your ship, your suit, your body, all of it, if the power failed, would approach 2.7 Kelvin and remain there, a perfectly preserved artifact in a void that nothing passes through and nothing disturbs, potentially for longer than the current age of the universe. And this is where things change. Because the distance itself, the sheer geometric non-negotiable distance between where you are and where you came from, is a danger as real as radiation or cold. And it is a danger with no engineering solution. At the speed of the fastest spacecraft humanity has ever produced, returning to Earth from the intergalactic void would take billions of years, not millions, billions. The Milky Way you are looking at is not a destination you can navigate back to on any human timescale without a method of propulsion that does not exist and may never exist. You are not stranded in the way a ship is stranded at sea, where rescue is a matter of resources and time. You are stranded in the way that a photon emitted by a galaxy at the edge of the observable universe is stranded, separated from everything else by a distance that expansion is actively increasing, by a void that is not static but growing, because the universe is not holding still while you try to cross it. The space between the Milky Way and where you are now is expanding. It has been expanding since the moment the universe began. The further you go, the faster the expansion carries you away from everything, until at a certain distance, the cosmological horizon, the expansion of space itself exceeds the speed of light, and any galaxy beyond that horizon is not merely unreachable, it is causally disconnected from you. Its light will never arrive. Its existence is real but permanently inaccessible. You cannot send a signal there, you cannot receive one. It is in the universe, but it is not in your universe, and the boundary between those two things is not a wall you can see. It is a mathematical consequence of how space expands, written into the geometry of reality from the beginning. But that's not even the worst part. The worst part is what the universe looks like at this scale. What the large-scale structure of everything reveals when you are far enough out to see it as a structure. Galaxies are not distributed randomly. They cluster into groups, into clusters, into superclusters, into filaments that stretch for hundreds of millions of light years, forming a pattern of interconnected strands and nodes with enormous empty voids between them. This structure, called the cosmic web, is the largest organization of matter in the universe, shaped by the distribution of dark matter, the invisible, undetectable, gravitationally active substance that makes up roughly 85% of all matter in existence, that we have never directly observed, that we have never touched or measured or captured in any instrument, that we know exists only because the universe would not hold the shapes it holds without it. Dark matter is everywhere. It is the skeleton of the cosmic web. It is in this void you are floating through right now, threading through the emptiness in concentrations we can infer but cannot see, shaping the distribution of everything visible without ever becoming visible itself. You are surrounded by something that constitutes the majority of matter in the universe, and that remains, after decades of the most sophisticated physics ever practiced by our species, completely unexplained at the level of what it actually is. And this is the universe at scale, not the solar system, not the galaxy, not even the local group of galaxies, but the full, honest, overhead view of everything that exists. It is a web of matter so thin that the voids between the filaments make the filaments themselves look like shadows. It is mostly empty. The matter is clustered into threads so fine, relative to the total volume, that if you compress the observable universe into a sphere the size of Earth, all of the stars, planets, gas, dust, and dark matter in existence would occupy less space than the period at the end of this sentence. The rest is void. Ooh. The rest is this: the temperature of the Big Bang's cooling remnant, the magnetic fields of ancient filaments, the expansion carrying everything away from everything else at speeds that increase with distance and approach and then exceed the only speed limit the universe has. In 2003, the Wilkinson Microwave Anisotropy Probe mapped the cosmic microwave background radiation across the full sky. The oldest light in the universe, emitted 380,000 years after the Big Bang, now cooled to microwave frequencies, arriving from every direction simultaneously, a perfect record of what the universe looked like before any star had ever formed. The map it produced showed tiny temperature fluctuations, variations of 1 part in 100,000, that represent the seeds of all large-scale structure. The original density variations that gravity amplified over billions of years into galaxies and clusters and the web. Scientists who worked on that data described a particular disorientation in looking at it. The sense of holding a photograph of the moment before everything, of seeing the boundary between before and after, between a universe with no stars and the universe you live in. That image is a map of the void you are inside. It is a record of the medium you are floating through. It covers everything, in every direction, without exception, because it is not an image of a place. It is an image of the universe looking at itself. The Milky Way behind you is still visible. It will remain visible for a while yet. 100 billion stars are difficult to lose. But eventually, if you keep going, the expansion will carry you past the point where its light can catch up with you. The photons it is emitting right now, at the speed of light, will be chasing you through an expanding space that is stretching the distance between you faster than they can close it. And at that point, the galaxy will not gradually dim and disappear. It will simply stop arriving, the last photon will reach you, and then no more will come, and the Milky Way will not go dark. It will go absent, not faded, not distant, just no longer in your universe. Every human being who ever lived was born inside that galaxy. Every civilization, every idea, every fear and hope and act of courage or cruelty or love happened within 100,000 light years of its center. The entire recorded history of our species occupies a period of time so short, relative to the age of the galaxy, that it does not register on any scale the galaxy would use to measure itself. We are an event so brief that the cosmic web does not notice us, that the voids do not acknowledge us, that the expansion carries on at exactly the same rate whether we exist or not. You are outside the only home our species has ever had, and the universe did not notice you leave.